Day to you. This is Anna Galactic on the 4th day of May in 2024 from Chico, California. This is an informal introjection into our unimetrics sequence. Because of the nature of our inquiry, we're forced to look in two directions. This is normal in science. One needs to first get a framework for whatever solution is being sought, and then one must employ the scientific method to drill down. The challenge that we face in this sequence is this is a rebasis of science itself, which already raises every red flag possible to someone tuning in, trying to pick up in this sequence to gain understanding of the universe, which is our goal here. This is astronomical science. We want to understand heaven, the ancient word for what is now called the universe. The universe is a very interesting concept, as we all can agree, because it's, of course, everything taken at once, which is difficult to corral. That is actually what we're going to do right now, is go through the sequence necessary for reconceptualizing space. Space is the basis of science. Ever since the time of Albert Einstein, we now must face the factor of time, which never had been faced in the history of science, because time has no quantification. We consider time from our perspective to be linear, and that is now known to be incorrect. It's not just inaccurate, it's completely ass backwards wrong. This casts a shadow over Einstein's field equation. This already is the top red flag, I would have to say, going in. As the presenter of the sequence that you're about to observe here now, you need to evaluate your own position with relation to science in order to cope with the incredible change which I am going to introduce now. This is no longer a theoretical proposition. What I have discovered in 2022 is a new number system. And it is new, although it's actually part of the oldest system of all. Our typical linear number system, it's not even typical, that's the wrong word. It's absolutely basic. And there is no way to deviate off the course of linear algebra. For 2,500 years, dating from Euclid, science is 100% constructed on the line invented by Euclid. You could say that because he axiomatized the linear system. He did so correctly, given his first proposition, which was the definition of the point. We just covered that in extraordinary detail. And the reason for covering Euclid's definition of the point is that he was not at all attempting to axiomatize the point as his primary goal, but he did axiomatize the point because it is the definition of his line. So that is the first jump-off point, but I'm not going to jump off that point now. Always a pun when one refers to getting to the point. In the conceptualization of space, it's extremely important to regard the words that are being used and the goal that is being sought. The universe is made of space, and the way it's constructed is spatial. There's no concept of time, and there's no concept of anything whatsoever in science except for linear spatial separation. That is an extraordinary statement to be able to make. And you won't hear any other scientists ever stating the case the way I just did. It's absolutely necessary to be perfectly precise because we're not fudging here. We must have an accurate metricization of space. Space. S-P-A-C-E. What is it? Can you define space? You might, or you might think that you can, or you might try. I suggest that you do, but not right now, because I'm going to define space correctly. There is only one way to define space, and that has never been discovered until 2022. My breakthrough sequence, which reconceptualizes space, is the most important breakthrough in the history of physical mathematics. I stand by that statement, and I'm going into the octagon with that statement, and I'm going to take heads. So you are about to get the most cogent, coherent introduction to the rebasis of science that I've been able to formulate thus far, which has been 3 years now. I've been working through and off and with this geometry in order to apply it, because in science, it's no good to have theories. Theories don't do anything except, perhaps, guide further research. If you come up with a theory, it means you failed. It is part of science to be at the cutting edge in failure mode. That's perfectly normal. We've always been in that mode. We've never gotten solutions except for extremely limited problems. With respect to understanding the universe. So, the only way to begin axiomatizing universal space is with a spatial metric. Metric is another key word. We have space, we have universe, and we have metric. We're not talking about numbers yet. I've been over very carefully the linear axiomatic basis of physical space, which dominates science 100% from beginning to now. There has been no deviation off of the linear algebra course, which was conceptualized thoroughly by Euclid. So it has been extraordinarily important in my sequencing to be absolutely sure we're all on the same page when it comes to the current axiomatization of universal space. Okay? Euclid began with the point because he had to axiomatize the point in order to make sense out of the line. The line is open, and this completely disregards reality. Reality was left behind with Euclid. He was a primitive, he was ignorant. He didn't really have much idea of what he was doing with respect to where we're at in modern physics. Nobody ever had to deal with curvature until just a few centuries ago, when the parabolic curve had to be studied in order to land shells on human heads. Okay? That's why the curve was studied. It was for warfare. The other forms of curvature, which have been studied over the past 2 to 3 centuries, are all virtually meaningless in terms of modern science. It wasn't until James Clerk Maxwell, Max Planck, Hermann Minkowski, and Albert Einstein that the modern age of physics began, and it hit us right in the solar plexus when it was realized that we must have a linearization of curvature. The methods and tools which were developed in mathematics in order to cope with this incredible new horizon of spatial perception, circular and spherical, resulted in three amazing tools. These are linear algebra tools, three of them, that define science today, unfortunately. The three tools are: first, sine cosine, sometimes called CIS for short, or CIS. Sine cosine, obviously, is two functions. We were taught this as if it were the absolute holy grail, but the only reason that we have sine and cosine parameterization of circular space is in order to cope with two componency space, just so you have a firm grip on what that means. Science only uses one componency space, only one componency space. Linear numbers. I've taught you in the past few presentations that this componentization of universal space has four names that we're familiar with, but nobody, to the best of my knowledge, has ever correlated those names, and so I'm going to give them to you now. The point, the linear number, the quantum, and the particle. These are identical concepts. Identical concepts. Quantum, particle, point, linear number, one componency space. However, the harsh fact, which no one is able to face, is that we're now dealing with two componency space, and that's what you're going to learn today, right now, without any need to go back to my prior lectures. So that's the first tool that was developed to access circularity in the plane. It's called CIS, sine and cosine. These are monumentally evil tools, and you will come to fully understand that, and you will join with me in deprecating that nasty system. It has led to the very worst possible result in science, the very worst possible result, a total fiction. That's what you're going to learn today in order to understand the true system which I discovered. I'm going into the octagon and I'm taking heads. There will be a showdown, or I will die trying. The second tool, which was developed in the 19th century approximately, was the complex number system, which is quite remarkable, and I've given several lectures on the complex number system. You won't need to review those unless you're wise, which I leave to you since I cannot control what you want and don't want. The complex number system is a hybrid two-componency system utilizing an amazing trick called the square root of -1. If you've studied the history of mathematics, you know that this was resisted at first because nobody at first could understand the new concept of imaginary space. And that's why the system has to be called a hybrid system. In order to make complex numbers work with the linear number system, which are the computable numbers, a function had to be invented that would translate complex numbers, which are two-component numbers that make a system of numbers, each of which has two components, that must be translatable to linear logic. And there's only one right way to do it. It's called conjugate algebra. This is an extension to the mathematics system, and it is equally evil because it misses. I won't go into that any further. I already have, and you don't need to know the sordid details. You may already know, if you're a mathematician, the complexities of the complex number system. It is the only system used in science right now, and that is a magnificent blight. The only thing worse than sine cosine and complexity, that would be complexity in the plane, by the way, is the calculus. The most destructive function that has ever been invented in the poisoned mind of man. And I will be forthright and point blank with you. The calculus system is what destroyed science. Almost single-handedly. The books that have been written on the calculus surpass in sheer pages all the combined works of science. You could put all the writings of science in one room, and in an adjacent room put all the books that have ever been written on calculus, complex numbers, and sine cosine, and I would guess that it would be commensurable. Enormous volumes of trash. And now, because of what the governments have decided during the Industrial Revolution all the way to the present day, all of our youth, all of our children, all of our young adults, and all of our teachers are absolutely chained to calculus. Chained to it. And without meaning to get emotional, which is always unwelcome in science except when I do it, the tragedy, the horror of entire colleges, high schools, and universities filled, packed like a seine net with sardines being hauled aboard the government empire slave system of mathematics is the realization of 1984, the realization of Big Brother, the realization of every conspiracy theory, carried to its logical conclusion for the total enslavement of the human mind to something so nasty, so destructive, that words cannot describe it. But I urge you to take a field trip to your local college or university during the height of the academic semester in midday and go to the computer room and just stand there for as long as you can take it and look at those kids with their faces pressed to a cathode ray screen, or whatever technology it is, studying calculus, which not one of them will ever understand. But in order to survive, they have to follow the rules of evolution which have been laid down by the government. This is how you'll survive, says Mr. Bigwig. You will study the calculus, and you will be confused for the rest of your life, but at least you're going to survive. It's either that or take up your position as the next homeless fuck. That's your only choice. If you're a thinking man, you're going to have to study their system. I am here to pull down those pillars right on their heads. So, the metricization of space is linear. It's based on the point. And the point is a 0D object. That's Euclid. And that's now. 0D. You know what that means? No lines. So if you have no lines, and all you have is a point, then you have something to which we have given a name. Nullity. Null. Nil. Nothing. Nothing. So the axiomatic basis of the universe to this day is nothingness. That is reflected in the highest mathematical formulations of man, currently reigning science right now, in a very peculiar, somewhat mysterious, or at least baffling phenomenon, the result of our linear algebra, the result of our Euclidean approach to the universe, that the universe is based on nothingness. And from nothingness, everything arises. And then when you get to the end, which is today, and you try to make sense out of your system that you've developed for 2,500 years, you get a mathematical construction called a singularity. A singularity. I have mentioned in recent presentations that there is a whole class of words that have been developed in physical mathematics that have two alternating definitions. The singularity is one of the keystone words in that evil system, because science only can have one definition for everything, never two. The quantum paradox results from having two definitions. We'll get to that. Two definitions of what? Two definitions of a paradox brought about by our linear algebra system is what? So, what is space? If you begin with Euclid, space begins with nothing. That is incorrect. Uni in universe means one. 0 is not the same as 1. And if you have a point as the axiomatic basis of your entire mathematics system, which is true, that was proved by John Horton Conway, by the way, and I completed his proof of what is a linear number. It is a point, which is null, has no meaning by itself, no meaning whatsoever. You could say, as we have been forced to say, that that point has to have some meaning. In mathematics, which is related to geometry, as we all know. So what is that linear point? It is nullity. It's null. It's not really a number. But the reason it has to become a number is because you cannot measure anything in linearized space without a 0. You're stuck with it. Why would that be a problem? Am I some kind of crank or kook just attacking the number 0 because I'm fucked up in some way? You better get past that notion, Charlie. 0 is an enormous problem in mathematics. Can you even Write it from your memory. Give an example of a problem that we have with 0. Of course you can. But I will add to the list the glaring defect of 0. The basis of the number system we use is 0, you understand. 0 is always there. You can't do anything without 0. But it's null? It's just the absence? Well, what is it then? There is a definition that makes sense. And this is the one that Euclid arrived at, and we found it useful ever since. The reason why the null point at the center of the linear system, called 0, the reason that that has value is because it represents spatial position. Position. You might ask, if you're clever, position in what? That's called the embedding space. That's a geometric term which you should master right now. What is the function of the point? Now here it's not just 0. Any point on the line which is redundant, any point on the linear line has no dimension. That's its definition. No dimension at all. That's because it's in an embedding space of one dimension. And this is where we get our idea of dimensionality. Completely misaligned with the universe. Okay, to jump ahead and not go down that path any further, I think you recognize that I have a new approach to the concept of a point. Yes, a brand new concept of the point which buries Euclid, but that's not possible. So am I making a mistake? Any mathematician worth his paycheck would argue me to the death, because his whole reason for existing as a logical entity, that mathematician will defend the linear number system blindly until he drops dead. Because without that, you lose sanity. That is true. But there is a reason why it's true that has eluded the greatest minds of all time. Why can we not leave the linear number system? The reason is that Euclid's axiomatization of space begins with the concept of a linear point. Unfortunately, or fortunately, and we'll merge those, we'll synthesize that. The strange aspect of Euclid's geometry, which defines science to this day, the point system, which is axiomatized on the first two sentences of Elements by Euclid, approximately 500 BC. It's not greatly important exactly when. Those dimensionless points, which are on the one-dimensional line, are numbers. And it's that simple. There's nothing else to say. Now, in the Industrial Revolution, it was discovered that we must have a better algebraicism, a better algebraic approach to curvature. Curvature was never a serious issue in science until the Industrial Revolution, with the footnote that I alluded to before. And suddenly, curvature became critically important to understand. And that was the beginning of the modern age of science, capitalizing on the discoveries made by Leibniz and Newton. Those two names are forever fused in our history of science because each one of them came up with a valid definition of the calculus, and they don't match. The calculus, as I said, is probably the most evil tool that has ever been developed by the mind of man, considering the effects of such a relatively simple idea. The calculus is not ultimately difficult, except for one monumental obstacle right at the beginning. The concept of the infinitesimal and the concept of the integral are lying, cheating, miserable, anti-scientific, anti-logical, anti-geometric conceptions. So, we cannot any longer use Euclid's definition of a point. However, we're stuck with it forever. And that has been proved, and I also was able to prove the same theorem. We will always use linear numbers for one and only one reason. They're computable. We use computers. Computers are extraordinarily efficient machines that extend our capabilities as logical, rational humans so that we don't have to do extraordinarily drawn-out calculations on paper or even with a calculator. We need supercomputers in order to run science now because of the extraordinary complications and complexification of the simple number system called the linear number system. The linear number system has a grievous flaw. It's not just 0, which is a derivative number on the line. I proved that in 2022, and we're going to cover that today. This is going to be a long lecture. So take a break now if you want to. Put this on pause. Get yourself some cool or warm refreshments, with or without alcohol, and get ready for the ride of your life, which, if I'm successful, will change your view of science completely. For the better. So we have a grievous flaw, the 0. Division by 0 shows that our system is magnificently flawed. It leads to extremely inaccurate calculations in deep space astrophysics. We've misformulated the supermassive black hole, which has now become something of a science fiction object. Nobody in their right mind would disagree with that statement. The supermassive black hole is in the realm of fiction. It's treated that way by the top physicists. And they have no problem whatsoever dancing around their error because they can't see the way out of the labyrinth. It results in the singularity at the center of the black hole. It results in the singularity at the beginning of the universe, which these maniacs believe that they're able to formulate now. They definitely are not able to do any such thing. They're living in a fantasy world. What we need as humans from science are rational answers, not guesses, not theories. We need to know! So I offer you that. The path to wisdom. In order to get there, you need to have full understanding. That's the challenge. We have the data. We have the structure, but we're lacking the linchpin that pulls it all together so that it makes sense. With calculus, sine, cosine, and complexity, you will never get out. You'll never get out of that system, and you'll never get any answers. Not to anything in deep space, not to anything in cosmology. You'll never understand galaxies. You'll never understand the black hole. You'll never understand the universe. And moreover, you'll never understand the building blocks. You'll always be locked in the quantum paradox. They are. You want to follow them? They're going to hell. Okay? So the key that unlocks this is to go back to Euclid and find out where he made his mistake. And that's why I'm here. And so now we begin our formal approach to the right metricization of space. We are dealing with space. But you know what? We better get time in there somewhere, right? Get ready. I'm going to show you this so you can freeze frame this and study it if you want. I'll have a document on this, but this is recent, and this is what we're going to talk about right now. So there it is. I hope you can see it all. There. Take a screenshot of that. This is the introduction to the bootstrap theorem, which I developed in 2022. Spatial metricization. Let's stop there. What are we talking about? Why are we what is this big word metricization? Do you know what a metric is? Do you know the meaning of a metric in space? It's how you measure space. Do you know how we measure space? You'd better, but I'll tell you the answer. So that if I give you a quiz later, you'll get it right. How do we measure space? LNS. Linear number system metricization. Okay, what's that? LSS. Linear spatial separation. The index of the metric of the line is 1. So now you know the role of 1 in the metric. It's the index of linear spatial separation is 1. And the distance from 0 to 1 cannot be divided. You may have heard of the work of Hilbert and the work of the lunatic. He died in an insane asylum. Cantor. Georg Cantor. He died in a lunatic asylum in Poland after creating, I don't know who said this, I've forgotten his name, but I think it was Eddington, who said that no one will eject us from the paradise that Cantor has given us. Let me rephrase that slightly to put that into realistic terms. What was being sought by Cantor, Hilbert, and an entire school which has risen to domination and now controls science? The attempt to make the line continuous. Continuous. Continuity. Key word. We're getting there. That's what's missing. and the desperate effort in the 19th century to make the line emulate continuity was disastrous. Utterly disastrous. For a very simple, logical reason, which these men either were too stupid to notice, or worse, they purposely disregarded the idiocy of what they were trying to do. Because the entire basis of Euclidean geometry, resulting in the computable number system represented on the line, is entirely due to quantization of the line. That means quantization of the space. That means quantization of the linear spatial system. Quantization. Those are called numbers, right? The standard model of particle physics is capitalized on that error, and they have an absolutely psychotic axiomatization of the particle, where those dunderheads insist that the line is continuous because of the calculus. It's the calculus that does the cheating to pretend that linear space can be made continuous. It cannot be, because if you made it continuous, you'd have no numbers. The entire basis of the number system used in science is the quantization of the line to the Euclidean point, which is null. All the numbers are null. Until you introduce the metric of 1, the distance, linear spatial separation from 0 to 1. Cantor said, lying in his teeth, for which I believe he paid, that the distance from 0 to 1 can be infinitely divided. No, it can't be infinitely divided. Idiots! So that's the fundamental lie of algebra. The fundamental theorem submerges beneath this fundamental theorem. You have built a lie. And that's why you have the quantum paradox, is because of your stupidity with your number system. Nobody's been able to realize that the line has a number system. Well, then the universe is lying to us. You want to leave it at that? Science is willing to do so. That's the state of science today. That the universe has lied to us. It's everywhere on the internet. In presentations of physics, of science, of mathematics, everywhere. Taken for granted. It's a fantasy world. The quantum cybernetic projection of the universe is on every lip now. Complete lunacy. Parallel universes. I could give lectures just on the insanity to give you example after example of these top-notch presenters on YouTube. They're also in the textbooks and universities and everywhere. Top-level physics. They talk about pure psychosis. They're comfortable with it. They have to be. They can't find their way out of the labyrinth. Okay. So now you understand the dilemma that science is in. It's using the wrong number system. What I am going to show you now is that that was necessary because we had to develop the linear number system first, for one reason and one reason only. to get the computable numbers. On a computer, we can define, with feedback from the universe herself, just what our numbers are capable of, how we can represent them, so that they perform mathematically correctly on a computer. The division by zero error must be captured. If you send a division by zero instruction to the CPU, it freezes the CPU. You're going to have to unplug and plug in. That's called a reboot, because your system is frozen, because you violated the law of the universe. And so your computers are all liars. We've programmed our computers to lie. That is unnecessary, and I'm going to fix it right now. We're going to fix the number system so that it works. It doesn't work. You must realize that. You can't have division by zero, you idiots. And all of your numbers represent a pure illusion. It has been useful to us. And with the development of the calculus, it's caused untold miracles to unfold on Earth. That induces a religious response in every human. Don't ever believe a man when he says he's an atheist. He's a liar. There's no such thing as an atheist. And any man, even Richard Dawkins, whom I respect as a human, although if we were friends, I'd have a serious talk with Richard about his lunacy. In science, you're not supposed to talk about God. I agree with that. But when a man violates that principle, which is commonsensical, of course you don't talk about religion and science, you jackass. Well, Richard Dawkins has signed himself up to be the chief jackass. And he goes right out and he's been writing books, and he's a very, very popular presenter. Because he carries the current lunacy to its religious conclusion. He says, not only is there no such thing as a designer, completely illogical statement, but he goes out of his way to make sure that you know that if you want to be a scientist, you're an atheist. Science is atheistic. Is it? Is it really? Is that right, Richard? You won't pay at my hands, Richard, but you will pay for that. You will pay for that. The universe has already decided. You can't get away with saying that, you maniac. You misguider of youth. You seriously demented. Yes, there is a designer. That's been proved by science. So, let's get going with our bootstrap sequence. I will be consulting this as we go along. You might want to take another break, get yourself some refreshments, put my pretty face on hold, and then get your ass back here to learn about the truth. Okay? That's the way it's going to be from now on. They don't call me the professor for nothing. So, we need spatial metricization, correct? How do we do it now? 0 to 1. With all of our maniac physicists and mathematicians saying, oh, it's continuous from 0 to 1. No, it's not, you liar. Because that would destroy the whole system if it were continuous, wouldn't it? Yes, it would. So how do we get continuity into the system? Why would we need continuity in the system? Well, you could ask Cantor, because he sure tried hard enough to make it continuous. You could ask Hilbert. No, he's dead, but If you could ask Hilbert, you consult his writings, you'll find out why he insisted that the line can be made continuous. Can it? No. So why do they say that it's continuous? They have no choice. And so they pretend that it's continuous, and then wonder why they have a quantum paradox. So, our linear system has an innate restriction. It's only capable of producing the linear numbers, which are computable. And our computers can prove that to us, and that has been done. All the work in computer science was for one reason only: to validate that our number system works. It does, if you use calculus to shave off the corners. That works for technology so well that men are inadvertently convinced of divine oversight in both senses. That the designer, whom they insist does not exist, invented mathematics for us. But the way they say it is to make sure that the designer gets no credit for it. They say it's a cuckoo clock. This is equivalent to locking the supermassive black hole in a zoo so everybody can throw rocks at it. The defamation of logic. So how do we metricize space other than with the line? Because the line has no continuity. It's quantized by nature. Nature quantizes the line, so we have numbers. What are those numbers for? If you say it's for technology, you lose. And you can turn this off and go back to your YouTube and back to your rubber ducky. The reason we have to have continuity in the number system is because the universe is continuous. It's not quantized. Our number system is quantized. The universe is continuous. That has been proved. So, do you see a problem there? You'd better. How are we going to compute gravity? Well, you may know that there have been two major formulations of gravity, but I'm not going to go into that now. I'm merely addressing your attention to the phenomenon of gravity. Gravity. Yes, gravity. What kind of a function is that in real space? Here's a multiple choice question for you. Is gravity linear or is gravity spherical? Well, even a school child knows that it's spherical. So where does that leave your linear numbers? Helpless. Helpless. No way to understand either the sphere or the circle. And neither one of them is understood. And I've given lectures on that. So what do we need then? If we could get it, which all the top scientists assume that this cannot be had. There is no solution. You're stuck with linear algebra forever and ever, whether it works or not. Too bad. Because it works for the government. And if it works for the government, end of story. It works for the government. We're not affiliated with any government. We're free men. We're free scientists. We're not paid by the industry. We're not beholden to the government. We don't kiss anybody's ass or any holy cow's ass. We consult the universe directly, don't we? You will now. You're with me now. So, what is the correct metricization of space? The first fact to which all of my hot air has been leading right now The metricization of space must be using linear numbers because they're computable. So we're back in the labyrinth, aren't we? That's the state of science today. We have to use the linear numbers. For everything we do, that is a fact, because they're computable. All right. You may ask, why is computability so important? Do some homework and find out. I can't go into that now, but it's been proved. We cannot leave the linear number system. Our attempt to do so was with complex numbers. And that's a most interesting system, which I cannot go into now, but I have lectures on the complex number system that fully explain why it's so miraculous. You must understand that the natural number system is no longer used. Not even the so-called real number system, the gift of Cantor. The continuous form of the line is the real line. The real line is the continuous line. You know it's pseudo-continuous because you can't get around quantization. Linear numbers are quantized on the line. That's tautological. All of this has been rigorously proved, so you must accept it. I do. And that was my major challenge when I discovered spherical geometry. So that's what we're going to define right now, is the correct number system for modern physics. Nothing less than that. Because gravity is spherical. Can you think of anything else in physics that's spherical? You might. For instance, in astronomy, what up in the sky is spherical? Well, you could begin with Earth. That's spherical. Do you know why? Do you know why the Earth is a sphere? All right, we look up in the sky. The first thing we see is the sun. Is that a sphere? Yes. Why is that a sphere? Then you look at the moon. It's a sphere. Why? And what is the path of the moon around the Earth? It's a circle. Why? Gravity. Correct? As part of the answer, there's a force. Gravity is a force. Gravity is a force. Right? Absolutely right. So what else in nature is spherical? Let's go all the way to the edge. Is the universe spherical? Every child knows that it is. Common sense says that it is. The mathematicians say no, it's not. It's saddle-shaped, or it's involute, or it's hyperbolic. They're liars. They're speaking from the point of view of someone lost in a labyrinth. And they're trying to understand their labyrinth, but it's made of lines. And they can't see continuity. So what's the relationship here between our number system and what we see in the universe? Well, our number system is quantized, but the universe is not. It's that simple. So what do you learn from that? Sphericity is continuous. The manifestation of sphericity and circularity, both in the solar system and all the way to the edge, is 100% continuity, no quantization. There is no quantization in the universe. Nothing is quantized. There's a footnote, though, and this leads us into subatomic physics. There's a sphere at the center of all things. What we call matter is based on spherical geometry. We've gotten down to the Bohr atom. That's considered to be the building block of the universe, and you can consult the periodic table to see the magnificent artwork of the designer in creating the atomic system. Approximately 100 elements exist, all based on the proton And the proton is a quantum. So the proton, by our own linear definition, is a number. The proton, because it has a point center and is particulate, which means it can't be divided, it's a unit, that means it's a number. So that's why we have atomic numbers. The number of protons is the universe's idea of counting. And is a number a point? Yes, according to Euclid, it has to be. A number is always a point. But a proton either is a point or it's not a point. Which is it? Which is it? Is the proton a point or not? Then we go to the electron, and then we go to the photon. That's the sequence we're going to cover, so that you understand the basis of the universe's idea of numbers and geometry and reality, not your professors, who are locked in a labyrinth and they can't get out. We're going to get out right now by identifying a new number system that the universe uses. This is what I discovered. So pay attention. So, spatial metricization is quantization using the linear number system. Correct? All right. So, the universe as space, we think, is based on linear separation. That's the only metric we have. That's why we measure the distance to a star on a straight line. That's correct. The photon goes on an impossibly straight line from the star to your eye. An impossibly straight line. It goes directly on a straight line covering any number of light years, bullet straight right from that atom in the star to the atom in your eye. Straight to it. Impossible, right? That's the quantum paradox right there. Now, Albert Einstein told us the universe consists of time. Isn't that an interesting concept? This has led to the most harebrained pseudo-philosophy ever heard from the poisoned mind of man in upper echelon physics and popular or popularized mathematics and physics. Time is up for grabs. Everyone wants to fantasize about time now. Time travel, the twins paradox, time dilation, paradoxes after paradox after paradox after paradox, focusing on time, where we have intuited as a collectivity of scientists that the answer has to be found in time, because Albert Einstein pointed us right at time. Time! Can you metricize time? You have to now, because Albert Einstein proved that there is a direct relationship between space and time. That has been proved. What I've brought out are the details of his discovery, which you never hear, because the essence of his discovery is geometric. And whether Einstein fully understood the nature of his discovery or not, nobody knows, because nobody can probe Einstein's mind. But I'm willing to at least guess, based on what I know of Einstein, his attitude towards the universe, towards reality, towards the designer whom he believed in, because he's a scientist and not a fake. He had to see it somehow. But unfortunately, Albert Einstein, being the amateur that he was, not really intimately involved in the deepest things of science, because nobody can be, because they're stuck with a linear algebra system until they can't formulate anything correctly. He tried to penetrate that barrier, and he was successful. The only tragedy in Einstein's discovery of relativity, the Einstein field equation, special and general relativity, the formulation of spacetime, which he got from Hermann Minkowski, but he perfected it, and he created a linear solution for gravity. A linear solution for gravity. You know it's wrong. We have to identify where it fails. It does fail, because where's the continuity? You see, the continuity is introduced into the system by virtue of time. When he included time in the space metric, yeah, we're back to the word metric again. Do you know what the metric is of space-time? I've given lectures on this, but it's important for you to try to face this, and don't be afraid. Don't think that these men are above you. They're not. They're just like you and me. It's just that they're blind, and we don't want to be blind. The whole purpose of science is to relieve blindness. So what did he do? He linearized time. He forced it to be linear. And by doing so, he created a 4-line system that cannot work. But since it's geometrically sound, according to the linear axiomatization of space, that everything measurable has to be on a line. You understand that's the basis of science. If you want to measure something, it has to be on a line. Well, that fails, because the quantum is not on a line. It's off the line. That's why there's a paradox. We cannot measure off the line. We fake it with calculus. That doesn't work, because you're quantizing everything. Albert quantized time. That was his mistake. He was forced to it by the system. So it's a miracle, I believe, nothing short of a miracle, in line with several other miraculous breakthroughs. It's a miracle that he was able to discover the relationship between time and space. Do you know how to define that relationship? You must be able to do so. What's your answer? What is the relationship, geometrically, between space and time? They're orthogonal. They are at right angles. They're perpendicular to each other. Well, since space has to be linearized, it is. In a 3-line system, that's volume space, 3 lines, a grid. Albert took that grid and added a 4th orthogonal line, orthogonal to space. But space is quantized. Therefore, time has to be quantized as well. And you know what quantization means? Linearized to a 1-component number. And that is what is involved in 4D geometry, is that time is linearized so that it has an identical characteristic with space. What is the identity between space and time that allowed them to be correlated? It used to be assumed that they were incommensurable. Einstein broke the mold and shows that they are commensurable. directly relatable using linear mathematics. And he discovered the secret of relating time to space within the confines of our hideous grid system. That enables spaceflight, so it's no mean feat. Without relativity, there would be no spaceflight. We cannot control craft in outer space without taking into account special relativity conversions and general relativity conversions for time dilation. It's called dilation because of a relativistic effect. That is an illusion. There is no such thing as time dilation. Time is continuous. That means it's constant. And it doesn't make any difference what anybody else says about time. Time is continuous. That means it's not linear. It's not linear. And so we cannot measure time. If you want to measure time, you have to go to Einstein's field equation. And there you will find time shoehorned into the three-line grid system of quantization. But you've maligned time, and you missed the truth, and you ruined everything. Now, Einstein gets credit for what he discovered, and I'm not taking away from what Einstein discovered. It's miraculous. We would not be able to travel in space without relativity. Well, you see, that arouses the worship instinct in humans. To worship the number system. It means that it's infallible. Infallible, is it? We just proved that it's the definition of fallibility. So what's the way out of this trap? I discovered the solution to all of these paradoxes in 2022. So, why is time continuous? Let me ask you this. Is space continuous? That's difficult to say right off the bat. You would have to prove your answer one way or the other. So is space continuous or not? If you want to measure the distance to stars, your answer has to be no. It's not continuous, or you can't measure. If it's continuous, you can't measure it. It has to be quantizable. And so we get the distance to the star in light years. Light years? Really? That doesn't sound like a one-component number. It's not. Light speed is a two-component number. And the measure of distance to a star is also a two-component number. It has to be. And that's why it's called light speed. Speed is not a one-component number. It's a two-component number. Light speed is a two-component number. So, the problem we're facing is we're dealing with a universe that's continuous with a number system that's anti-continuous. Those don't match. So what do we do about it? I just gave you the clue, so you may be able to guess. Well, what we need is a two-component number system. And it's magic what happens if you're able to devise a two-component number system. We tried with complex numbers, which are miraculous, because it's a pseudo-answer. It's a partial, you could say it's a partial derivative of the right solution. That's actually true. Because you're using calculus to get your answers, you've admitted defeat. Because once you use the calculus, you lose. Because the calculus has only one purpose. It's to get a one-component number out of two-component space, where space is being used geometrically now. It could be the space of time, or it could be the space of space. And if that sounds funny to you, I suggest you wipe the grin off your face. Okay? So motion is where we get the concept of time. Think about that for a second. Does that sound rational? Does that sound true? Could I prove that? Oh, I already have proved it. But it's actually very well known. The concept of time is not derived from space. The concept of time is derived from motion. Only motion yields the concept of time. It's the aspect of the universe that is non-spatial. It's the non-spatial. That means, I think you know what that means. Albert showed that the structure of the universe, the fabric of the universe, is space-time. That is correct. That's absolutely correct. So not only did he get the concept of space-time, which is correct, but he was able to show the relationship between time and space, that they are orthogonal. I've proved that Einstein got that right, but by a proof that nobody knows yet. So I'm going to share it with you now. Get yourself something warm to drink or something cold to drink, because this is going to be a long lecture. Okay? You don't have to watch this in one sitting. I have to deliver it in one sitting in order to give you the continuity necessary to grasp the result. Okay, so that's very important in a science presentation. Continuity. So be sure, if you do break this up into visualizable segments so that it doesn't grow tedious, if you feel weary, turn this off and come back to it later. But don't wait too long, okay? So we now have a concept of space and of time, and since time is involved, motion. Let's go on. So we know what the metricization of space is now. It's quantized on a one-component linear system. All right, you got that. We need to remetricize space so we can include time. Well, there's only one way to do that because they're two different data types. Time is not measured in spatial coordinates. Time is measured another way, and nobody's been able to figure out how to do that. I'm going to show you the way to do that. That's watertight, absolutely watertight. And this is called the bootstrap induction. So I'm just going to read this through and then we're going to get into the proof, and then you'll know. And then you'll have it forever. And you'll be able to tune in from now on and follow these lectures all the way to the conclusion, where we're going to get the definition of reality and consciousness. And if you think I'm kidding, you're sorely mistaken. I've got the solution to everything. That's what you're involved in now. And good luck, because you will be a pariah. To the degree that you are able to include this in your rational approach to the universe, you will not be understood any longer. You'll be on your own. But I'll be here, and I'll support you. There's nothing you can do to help me. But I'm going to do my best to do everything I can to help you. All right? That's my goal. It's not to be mean, but this is dead serious, and I have quite a ride ahead. All right. So, we started with the Euclidean point axiom. We now need to switch. So we need to go back to the beginning of the universe and reconstitute the universe according to the new number system which you and I are going to derive from original axiomatic principles that have so far eluded everybody, from Euclid to Einstein to Feynman to the present day. Nobody has ever seen their hand in front of their face with the obvious solution, and I'm just going to tell you that I know exactly why nobody else has been able to see this. Because I've had to go through the whole fish ladder sequence One paradox after another, in sequence, not skipping a step, to get the correct axiomatic basis. So this is how it's done. We have to reconceptualize the point, because Einstein got that from Euclid, and that results in an inaccurate, ultimately useless definition of universal space. It's absolutely wrong because there's no continuity anywhere. Do you know how continuity is forced into the Einstein field equation? Hypercalculus. You may never have heard that term. Learn it. You want to learn about relativity, gravity, space-time? You need hypercalculus, which means you're stuck in their labyrinth forever and will never get out, and you'll never understand anything. That's the harsh fact. So, we need a spheric point axiom, not a linear point axiom. We're going to start over. There are no points, there are no lines, there is no nothing. But here's where Euclid comes in. We know from how the universe taught humanity how to make numbers that you must start with a line. And that's what we're going to do. And from the line, we're going to derive the correct axiomatic definition of the point, on which everything depends. And this is going to be a challenge to you, because it's going to defy everything that you were taught in school. That is where we're at with the quantum mechanical paradox, and that's where we're at with cosmology, and there are deep, magnificent repercussions on deep space astrophysics to describe macrospace objects, beginning at the galaxy and going all the way to the cosmic microwave background radiation, the supermassive black hole, and the quasar, and the formation of spiral galaxies and the formation of elliptical galaxies. None of this is understood because nobody has the right geometry. It has to be spherical. So we're going to get a spherical geometry, and from that we're going to find the spherical number system, a two-component number system. That's what we're going to do right now. Let's begin. Empty space. Empty your mind. You now have a blackboard in your mind with nothing in it. The universe before it has anything in it. This is called a geometric space. It is a metaspace. It's only in your mind. The object is to match the mind to reality. That's what we're going to do now. Empty space. Dink, make a point. We're not saying anything about it. But we're going to say that it's a Euclidean point for now, so that we know what it is. It's a dimensionless point, which means that it is a position. So we have one position, and that's the first step. One point in empty space. Now, we know what to do next according to Euclid. This must be followed in order to get the linear number system. We're now going to get it correctly. Here's how. There's the point. We have nothing else. Everything else is pure emptiness. All we have is a position. Now, we use Euclid. Make the line. We're going to do it slightly differently than the way Euclid did, because he had a directed end. When he created his point, it was with a view toward the line, because the line is what has the linear computable numbers. That's redundant. So what we're going to do is slightly different from Euclid, but it is Euclidean. We're going to make the line as two reflection rays. Now that might sound daunting. It's not. Watch. And do this with me. There's the point. Now, we're going to turn it into a line. Here's how we do it. Take your fingers and make these little pinchers. With 3 fingers, take your little pinchers and grab the point. And now we have a point that we're going to stretch linearly with a double ray. This is a polar reflective ray. You could do this, right? That's a ray. Where does it go? Infinity. So it begins at the point to which we do not assign a number. It's simply a position. That's a geometric term. It's a position. From this position, we can do this. That goes to positive linear infinity. Okay, that's obvious. Now, do the same thing but with the reflection. Pull, pull, pull. Now let it go. Where does it go? It goes to 2 infinities. Be more specific. It goes to 2 linear infinities. 2 linear infinities. How far away from each other are they? Difficult to answer, isn't it? Because if you just make a ray, it goes to infinity. Where does the other ray go? This goes to negative infinity, correct? All right, so that's all we have so far. That's step 2. We have now a polar infinite object. Polar means that it has a center because the 2 infinities are equivalent, correct? There is no difference between this infinity and this infinity, but geometrically you can state the relationship between the 2 infinities. They're polar opposite linear infinities. So that's step 3. We now have 3 things. We have a center, which must be the center because these 2 infinities are exactly equivalent. And so the center is the point. And it has no numeric value. We're just doing geometry. All right. The next step is the key to the transformation, and it involves you being able to visualize the space in which you're working. Remember, this is only in your mind, but you can identify it with an empty universe in your mind, which now has a single object in it, a straight line. So they are now looking at a line. It has no mathematical value. It has no points except 1. It has a center. And it also has 2 endpoints. Except they're strange, aren't they? Because it doesn't end in a point. But if it did end, it would be at a point. Correct? That is tautological because it's on a line, and a line is nothing except points. But we only have 1 point, the center. So what can we say about the 2 infinities? What's their relationship geometrically? The obvious answer is, the one that I gave, they're polar opposites on the line. So the 2 infinities have no existence except with respect to the center. So where is that line? It's in space, right? Okay. What's the shape of the space that the line is in? Is it linear? Here's where you need to stretch your mind, and you're going to have to take a step that every mathematician, geometer, and scientist has to take in a hypothesis step. You have to go out on a limb and make a statement that hasn't been proved yet, but you're asserting that you can prove it. Very interesting setup. It's called the hypothesis step in the scientific method. So this is the basis of science. We're now employing the axiomatic basis of science itself using the scientific process by declaring a hypothesis which we will then prove. So we begin with a statement which you may not be able to accept. That's why we need the proof step, so that you will accept it, because I am not the one saying it. Science is. The universe is. So what does the universe tell us about this straight line in empty space? Here's what it says, and this is our hypothetical statement that we will prove. That line is embedded in a sphere. Think about that. What's your reaction to that? Do you think that can be proved? Here's how to prove it. When you have the line and it's touching two infinities, is that indeed two infinities? No, because the line has no meaning except inside of an embedding space. So now we're going to define universal space, so we have an actual space. Right now we have no space except the line. You know that Euclid called that an object that has length but no breadth. So that's linear spatial separation. That's what that's what Euclid meant by saying that it has length but no breadth. That is the definition of 1D. We are not making that definition, but we are going to derive it. We're going to derive Euclidean space. But first, we have to know from what are we deriving linear space, because this is not space. What is? We can prove what space is from the line. Because the line hits two infinities, it can be proved, and I'm going to prove it now, that that line is embedded in a sphere. And the hypothesis step is to say that the two infinities of the line are one infinity in spheric space. So now we have a sphere that is infinite. Does that sound like a reasonable definition of the universe? I say that is the only reasonable definition of the universe with which you must begin in order to make any progress on a rational, supportable basis. It has nothing to do with the line and nothing to do with quantization yet. But we're going to need to quantize the space to get numbers. That's what we're leading up to. That's a second theorem. This might be a healthy time for a break. I cannot take a break, and I won't. But you should if you feel you need refreshment. All right, welcome back. Taste and see that the Lord is good. That's exactly what we're going to do right now, is come forward and taste and see that the Lord is good. Because He's the one that developed this. I'm merely echoing the words of the designer. He spoke to Euclid somehow, He's spoken to me. And if anybody thinks that that's kind of outside the bounds of science, you're welcome to your opinion, Richard Dawkins. And good luck to you, you sour old man. All right. So now we've hypothesized, those are synonymous words, a empty spherical universe that has an infinite edge. Because when you draw a straight line, it hits that infinity at 2 points. Correct? That is called the diameter of a sphere. So that line is embedded in a sphere. We know the exact numeric relationship between the surface of that sphere and the diameter on the line. That is a fixed relationship having to do with the irrational number called tau, which you will know as 2 pi. Those are synonymous. Tau is a number. But we're not going to get into the number system yet because we're not done axiomatizing space. So far, our hypothesis is that the line invokes the sphere. And whenever you draw a line, such as we just did, you automatically drew a sphere, and that is the embedding space. Now, we have a geometry. But it's not linear. But the line is in it. That's where the computable numbers are. They're on the diameter of the sphere. Now, because the diameter of the sphere is actually 2 rays, correct? We only use one of those. Right? That's called the radius. And that defines both tau and pi. Because the relationship of the diameter to the sphere, and here I'm going to have to introduce the notion of the circle. Because a diameter of a sphere, visually, to us, that's the diameter of a circle. So for now, I'm going to just say that this is the diameter of a sphere, but it's easier to visualize as the diameter of a circle. And you will see, as we proceed, that these two objects are extremely closely related because they're both closed lines. The circle is a closed line on the plane, and so that's helpful to us because we're so stuck in linear logic that the circle makes much more sense to us because it's a linearized sphere. Because if you take a sphere and collapse it, it's a circle, right? That's how closely related the circle and the sphere are. I just threw that in because the diameter is most often associated with a circle. Now, we're dealing with a sphere because that's how we perceive the universe. We do not perceive the universe as a circle, but it's easier for us to do so in most circumstances because it's linearized. All right. Disregard that if that confused you in any way. I just wanted to put into the mix that the circle and the sphere are going to be just a bit ambiguous at times, which is which. It does not affect the outcome at all. We're going to say that it's the sphere. And so the radius of the sphere has a direct relationship with the sphere called tau. If you extend it to the diameter, the relationship of the diameter to the sphere is pi. And the ancients chose pi because the top half of the circle, which is what they were concerned with, is positive in the y direction. disregarding negative y. It just is easier because the negative part of the circle or the sphere is simply the reflection of the top half. You can see that that's kind of, which one is best? Should we use the diameter or the radius? I think you know that the radius is the one we should use. That is correct. But we'll get there. So we're going to say that this sphere, which has an infinite surface, it's infinite, right? Of course it is. It's infinite. All right. We have to somehow quantize that. Well, that's very difficult to do. How do you quantize infinity? This is the secret of the universe, which I discovered. It was just given to me, and this began my course in discovery science, when I realized, through studying this exact geometric approach to see where it led, it leads to a very interesting second hypothesis. Our first hypothesis is every line defines a sphere, and the sphere is original, and the line is derivative. So we began with a derivative. That makes sense. We're very small. We're not gods, and we don't perceive the universe as such. We have to now. That doesn't mean we're going to become gods, but it's going in the right direction. All right? A little philosophy there for you to mull over if you choose. At our next break, you may choose an inebriating beverage. I often do, but I won't now. Oh, this is amazing stuff. Okay, let's keep going. So our second hypothesis is that the edge of spherical space has to have a number, or we can't deal with it. That's actually the legacy of science to the modern day. We don't know what to do with spherical spatial infinity. But that's what the universe says that it uses. We just proved it. When you draw that line, you're making a sphere. If you go all the way to infinity, you made the universe an infinite sphere. That's how we perceive the universe. That's true. All children do. All adults do too. There's no way around that. And don't let anybody tell you that the universe has any other shape than spherical. Otherwise, you're going to get lost in their labyrinth again. They would love to have you, because misery loves company. So now we have an unbounded sphere. We axiomatically proved that the universe, this is metaspace, remember, but we're trying to match real space. So far, so good. We got a handle. We haven't proved anything yet, but we're saying hypothetically, and whatever we say must be provable, so I'm going to say what I'm able to prove and then prove it. That surface, the infinite spherical surface of universal space, must have a number. What is it? Let's find out. All right, here we go. This is called the bootstrap theorem. What I just demonstrated to you, I call the antipodal theorem, because these two infinities on the line are antipodes. That means polar opposite. Always that means on a sphere. That has been proved. When you draw the line to two infinities, you create the sphere. That is the antipodal theorem. That has been rigorously proved. But in order to see it fully, we have to complete our construction of metaspace, which we have not done yet. There are no numbers. But what do we have now? Remember, from our beginning, we started with a point, correct? Without defining what it is. Well, the first definition of what it is when you draw the line. So the point is the center of that line. That's true. Convince yourself of that now. That the point, as we're defining it now, is the center of a line. But the line defines the sphere. And therefore, that point with which we began is the center of unbounded spherical space. Convince yourself of that now. Because as simple as that seems, that's the turning point. There's only one point in this system, the center. And so that has to have a number. Okay, you may be thinking ahead. Remember, we've already decided, although we don't want to be biased, part of our hypothesis includes the possibility that we could use, perhaps, a two-component number for defining whatever we want to define in our space. We're now going to hypothetically state that we can do that. And then we have to prove it. We're going to do both right now. So we have an unbounded sphere that needs a number, and it has a center that also needs a number. So we need two numbers, and we're going to just suggest that perhaps, since we need two numbers to metricize the space to numeracy, that the formula for the number will be two linear numbers. We have the linear numbers on the line. They're embedded in spherical space. Let's use them. We can't. We don't have any numbers yet. This is the glitch that I believe blocked our greatest thinkers from ever realizing the most simple approach to this problem of metricizing space. First of all, you must assume that it will be a two-component number. And second of all, you've got to be able to prove afterward that the numbers you're using are indeed linear numbers to parameterize the sphere. If it's a two-component number, we're now going to hypothesize that this can be done. And everything now depends on how we use linear numbers to make two-component numbers. Because the components in the number must be linear, or we can't compute it. All right, good. So, we're now going to assume that we have at our disposal linear numbers. We know, just from the progress of science, that linear numbers are real. They're real. Don't let the word real confuse you, because the real number system was grossly misnamed. We are composing the real numbers now. But in order to compose the real numbers for spherical space, we must use linear numbers, because only the linear numbers are computable. So how can we begin? We can begin by capitalizing on the most important number in the universe. And I leave it to you. Try to guess. If you don't already know, or you're not confident of your answer, don't be afraid. What is the most important number? It's 1. Right? 1. Now, just to give us a firm basis on our axiomatic step, in order to prove what we want, which we haven't even stated what it is yet, but we do have the framework, we're assuming that we can parameterize the sphere in the same way that Euclid parameterized the line. And how did Euclid parameterize the line? Points. So how are we going to parameterize spherical space? We don't know yet. But we know one thing. It's not going to be a line, because that's derivative. It's smaller and it has a different characteristic. The line is open. The sphere is closed. All right, that's very important in the long run, that you understand the difference between the two kinds of line. There's the straight line, which composes the linear numbers, and that's embedded in spherical space, so we have access to those numbers. The metric of the line is 1. No matter what Cantor tried to do in his insanity, which Hilbert went along with and all the industrial scientists have accepted ever since. Pseudo-continuity. There's nothing between 0 and 1. That's a quantum jump. And what's between 0 and 1? Nobody knows. But it's baffling the shit out of the physicists at the quantum level, because they cannot see anything that deviates off the linear system. But the quantum is between our numbers, and there's nothing we can do about that. And that's why the quantum paradox cannot be solved with linear algebra. It never will be. But that doesn't mean that it can't be solved. It can be solved by adding continuity to the number system. There's only one way to do that, a 2-component number. How can we prove that? We begin by capitalizing on the special nature of 1. 1 is the most extraordinary number in the universe, and it is the reason for uni in universe. It's a 1-verse. And now we're going to say that the universe has a numeric value. We're going to say that the universe has the value of 1 over 1. That's a proportional number. It's actually a spherical number, but nobody knows that yet. That's exactly what we are going to prove now, is that 1 over 1 is the basis of the original number system of the universe that it uses. And we've never used it. And here is an interesting way of stating that so that you can memorize it. This is a mnemonic of extraordinary value, which I will teach you now. It is not difficult. How many identity numbers are there in mathematics? Do you know? There are 2. You learned this about in the 2nd or 3rd grade, but I'm going to refresh your memory. 0 is the linear identity. That's why 0 is at the center of the line for linear space. Correct? Okay. What is the other identity number? It is 1. And it is the identity in what we call multiplicative space. Okay? So those are the 2 identity numbers. It's very important that you know why they are called that. It's because 0 is the additive identity. What does that mean? Count. 1, 2, oh, what am I doing wrong? Let's do that again. This is the metricization of the line. 1, oops. We have to go in 2 directions. Oh yes, of course. 1 splits. There's a -1 and a +1. Everybody knows that, but nobody ever thinks about it. 1, 2, 3. You're counting to infinity. 1. What is strange about that? Your number 1 is split. Positive negative 1, positive negative 2, positive negative 3, positive negative infinity. That is the polarization of spherical infinite space. We're developing the geometry from scratch. The line is derivative. Now, we need the number 1. And this is part of our hypothesis. We're going to say that the universe has a value of 1. And now to get the number system that describes all of space, we need to fill that space with numbers. When you make the line, you fill it with numbers. You fill it with linear numbers. When you make the sphere, you fill space spherically with spherical numbers. What do they look like? We've already guessed that they're two linear numbers in proportion. Correct? Absolutely. Now, consider the multiplicative identity of 1. What makes that an identity number? All right, on the line, the linear center is a 1-component center. We know what the value of that is now, although it took a long time after Euclid to understand 0. It has to be at the center for the line. So for the line, the center point is 0. What about in spherical space? You could say that that point has a linear value of 0. That's true, and that can't change. We cannot change the linear number system. We have to use it the way it is. So it's embedded in spherical space. So how can we derive the line from the sphere? Do you know? So the multiplicative identity means this, that when you multiply two numbers together, they make a different number, except when one of the numbers is 1. Just as when you add two numbers, they make a different number, except when one of the numbers is 0. That's a very brief, accurate definition of an identity number. It's the number that does not affect the operator in the production of the resultant number. So 1 plus 0 is 1. Negative 1 plus 0 is negative 1. It doesn't move the number, it identifies the number. 1 plus 0 leaves you at the same position. That's why it's called the identity number for the operator. What's the operator for the line? It's add. What is the other operator? It's multiply. Okay, so the center of the linear number system is its identity number, right? So we're going to say that the center of the spherical number system is the multiplicative identity number, 1. Okay, so now we have a number for our space. Where is it? We don't know yet. Is the one at the edge? We don't know. Is the one at the center? We don't know. This is the mind trap that no great mind has ever been able to solve. I solved it, and you're going to solve it with me now. Where is that one in spherical space? It's the identity number for spherical space. That's our hypothesis. Can we prove it? Here's how. We have two things that we need to give numbers to see if we can formulate a number system for spherical space. That's already been done for the line. The line is composed of quantum numbers. 1, 2, 3, equidistant, linearly. That's called the metric of the space. What we need now is the metric of spherical space. The metric of linear space is based on the identity center. That's called the Archimedean balance point of the space. That's the geometric use of the word space. 0 is the Archimedean of linearity. We're going to hypothesize that 1 is the Archimedean of sphericity, and now we're going to prove it with the bootstrap theorem. The hypothesis step comes now. We will assign a 2-component number to the edge and a 2-component number to the center that capitalize on the multiplicative identity. Okay, how do we do that? We need two 2-component numbers to begin. Look at the line again and imagine that these are 2-component numbers. That everything in linear space, if it were 2-component numbers, what would they be? Okay, try this. 1, -1, 2, -2, infinity, -infinity. What do those add to? They add to 0. All of the numbers add to 0 on a polar relationship. This is a 180-degree valence. 1 and -1 are opposite of each other with respect to the identity number. 0 splits to 1 and -1. John Horton Conway proved that. The linear number system splits to a split 1. So the first 2-component number, if that were ever to be tried, no one's ever tried that, but we can do so in our head. If all the numbers were composed this way, as 2-component numbers for linear space, the first number, the metric of that space, would be 1, -1, with the operator defining their relationship, so that the -1 and the +1 add to 0. -infinity and +infinity add to 0. So the line is balanced on 0. What can we do with the number 1? We want to make 2 numbers that balance to 1. Yeah! That's the insight. Now let's complete the proof. What's at the edge? Infinity, right? Let's give it a number. It has to be a 2-component number. Well, then we're done. We're dead in the water. No, we're not. Infinity over 1. That's our first number. How do we balance that in spherical space? 1 over infinity, because they multiply to 1. Right? Infinity over 1 is now our edge number. The center number is 1 over infinity. Now we need to define infinity so that it has a numerical meaning. What is the meaning of infinity in our number system? We have now located infinity in 2 places. We know it's at the edge. It's the definition of the edge of the universe. It's a number. But if you say that it's linear infinity, you confuse yourself and confound the system. Because a linear number system has 2 infinities. What does spherical space have? Well, it only has 1 infinity, right? The edge. Well, what's at the center then? Well, we just found out. It's another infinity. Stop right here. I wish you were able to ask me questions right now, because your mind must be reeling right now if you're getting this. The center of universal space is an infinity. It's a very specific infinity. It's 1 over infinity. Think about that. What kind of a number is that? It's an infinity. we can be more specific, and here we can capitalize on the insights of Leibniz and Newton when they dealt with this infinity, right? The infinity going in, right? How do you arrive at the center? Does it have a numeric value? We're saying that it does. The center of universal spheric space, the way we're constructing it, because it has an unbounded, infinite edge, if we give that a number proportion to 1, that has a reciprocal and multiplicative space such that the other edge, which is the center, that's an edge now. An edge. It's not a point. It's an edge. Because the edge of the universe is an edge. So the characteristic of spherical spatial infinity is that it is an edge. An edge. Learn a new word? Surface. Surface. So, the universe has an outer surface of infinity, correct? Yes, that's our hypothetical statement. Now we need to prove that that has some value of some kind. Let's go on. This will be a long lecture. It may go to 3 hours. Take a break now if you need one. Put this on pause, but come back. Don't stay away too long because you need to maintain continuity so that you will understand this fully. Because this is the reconstitution of the basis of science itself in a new way that nobody has ever seen before. And this has extraordinary repercussions that you will start to see immediately. And this will not end. This leads to every kind of discovery that breaks the logjam in physics today, is to adopt the correct number system of the universe. We need it now because we discovered the universe 1 century ago at both edges. We discovered the edge and we discovered the other edge. The outer edge is called the Big Bang. We'll reformulate that so that it's correct. It's incorrect the way it is because it's linear. And we have discovered the center of the universe. And that's called the quantum paradox complex. We're going to solve that as well. So, we have an edge number and an inner edge number. This is the outer edge. This is the inner edge. Change the word to surface. The outer surface and the inner surface have numbers. What kind of numbers are these? Well, they're both infinity, but they're spherically opposite. They're spherically polarized. Polar means 180 degrees. This does not mean 180 degrees, but with our linear perceptual space that we've developed by evolution, I believe it's blueprinted for us to, well, actually, it's been proved. We're physiologically blueprinted to see straight lines, and therefore, we have a linear logic system embedded in us that cannot be invalidated in any way. We are absolutely reliant on the linear number system for computability, but in order to get continuity, we have to reformulate space with continuous numbers. That's what we're developing. The continuous number system, not quantized. We'll have to quantize it to get separation, but it will not be linear separation. It will be spherical separation in spherical space using a spherical metric to measure a spherical universe with numbers. Okay, we now have the first 2 numbers. The number at the inner surface and the number at the outer surface. Remember the line? The two infinities add to 0. In this space, the two numbers multiply to 1. So now we have our first whole number in space. What does it look like? This number at the outer surface is infinity over 1. The number at the center surface is 1 over infinity. When you multiply them, they multiply to 1. The center number is smaller than any linear number. 1 over infinity is defined as the smallest number. It's the smallest number in the universe, and it is finite. The center has to be finite or it would not have locality. That's a term from quantum mechanics. We're getting into it rapidly. So be sure you follow these steps. Okay? Now, because it's infinity, and infinity is not a number, we are forced to make a profound statement about infinity. And this is mind-boggling, I hope, because it's true. Infinity is what? What is the characteristic of infinity? What is the numeric characteristic of infinity? It's a term that we can adopt. It already exists. There's a term that it describes the characteristic of infinity as a number. What would that characteristic be? Remember, in the complex number system, there's a real component and an imaginary component. It's imaginary. This is imaginary space in every sense. It's infinity. Infinity is the definition of imaginary space. Why? Because you cannot imagine it. So the only way we can identify what the number infinity represents, it represents numerically a number that we cannot imagine. And that's consistent. It's an imaginary number. What does that mean? You can't use it. So that's another mind glitch because of our linear way of thinking, which is blueprinted into us. But here's where you make the quantum jump to the reality that the universe prefers that you will see because you're seeking answers. So this is for someone who's motivated to know the truth. That's what science is all about, isn't it? Provable truth. Well, for this provable truth, you're going to have to incorporate imaginary space because the universe, as a sphere, is embedded in imaginary space. And here's the kicker. The center of that sphere has to be imaginary. And that's the correct definition of the point. There's only one point in spherical space, the center. And that is a non-zero number. There actually is no zero in this number system. You know why? Because in real space, in reality, the numbers that are used in reality do not include the linear derivative number 0, because we're in integral space now, and I will prove that to you. Now we have the unbounded sphere beyond which is imaginary space. That would be everything then, including infinity, which is now imaginary, but it's there. And it is a number. It's an imaginary number, lazy 8. But now you can see that the lazy 8 is a continuous line the way we draw it. It's not a cross, it's not an X, it's not a triangle. What is it? It's this. Something that we cannot imagine. That's called continuity. So, if the universe actually were continuous into infinity, then it's incomputable. But if it also has a center, which it does, and that has a value that's not infinity, it's the reciprocal of infinity, isn't it? 1 over infinity is infinitely small. We can't imagine it, but it's real. Does that sound like a contradiction? It does to me. Let's keep going. We have an imaginary center, and we have an imaginary edge, both of which have a 2-component number assigned to them. When you multiply them together, you get the number 1. Correct? The same as when you add +1 and -1, the balance in the system is on the Archimedean of the identity for add. This is the identity for multiplication, but I want to teach you a new word. Multiplication is the wrong word, and division is definitely the wrong word. And actually what we're looking at with infinity over 1, that is not a division number, and no fraction is. Division is not implied. You can force it if you want, but it doesn't work on the line because of 0. So division is not a linear operator. I proved that in 2022. I'm repeating the proof for you now. So 1 is a very special number because it's at the center of the universe. The center of the universe. That's the center of the metaphysical space we're creating in our mind, okay? Which now includes that which we cannot imagine. And we've given that a number, infinity. So now we're going to put infinity into the number system by rationalization. Okay? This is the rationalization of imaginarity, so that we can use it numerically, so that it's real, not imaginary. We must have infinity in the system, because reality dictates we need infinity, because the universe is infinite, but we have not fully realized the nature of the infinity of the universe. And here's how we rationalize that. When the center is 1 over infinity, we accept that as a legitimate number that will never be used in the system. It's a meta number. It's a number which will never be used, because in order to compute the universe in any way, it must be finite. It must be finite. And so we have to create a finite universe out of the infinite universe. That is exactly what we're doing. And here is the completion step, and I hope this locks in your mind. Here we go. The number at the edge is infinity over 1, correct? Picture that edge now with me. Here's the spherical edge of the universe. At that edge is the largest number of all. It's the largest finite number. That can actually be defined, and Max Planck gave us the key to finding that number in the wavelength-frequency relationship. We're going to dive right into that as soon as I'm done with this sequence, but that's where we're headed. The quantization of spherical space. That involves what's called the quantum jump. In linear space, the quantum jump is from 0 to 1. In spherical space, the quantum jump is from the surface of the sphere to the first number. We have not composed the first number. If you think of the line, it has 1 and -1. That's the quantum jump. When you quantize the line, you take the quantum jump from 0 to 1. In spherical space, when you multiply the two numbers together to get the surface, that is not 0. And you may remember that 0 has no surface, according to Euclid. That leads to the singularity, because you cannot divide by 0. And so 0 does not work in spherical space, because it does not work in proportional space, because you cannot proportionalize 0. But you can proportionalize 1. And so, according to John Horton Conway's surreal number tree, 0, 0 is the first, is the meta number. It splits to 1 and -1. That's day 1 of the surreal number tree. Take the positive 1, it splits to 2 over 1 times 1 over 2. That is the first counting number in spherical space, and it is 1. For the reason that that is the center number. Just as 0 is the center of the line, 1 is the center of the sphere. But here is where your mind is going to stretch, and I hope it doesn't rip, or we'll never hear from you again. You'll go right to the insane asylum along with Georg Cantor. So I pray you don't lose your mind. But it doesn't really make sense to say that 1 is the center of the sphere, does it? No. But it does make sense to say that 1 is the center of the infinite sphere. It's the center of the infinite sphere. Has a value of 1. Why? Because what's inside of it is the center we already defined. 1 over infinity is the point at the center of the 1, which is now a sphere. Why do we know that that 1 is a sphere? It's because the smallest number in the universe is the point. It's not 0. It's 1 over infinity, but it's imaginary. But it's there, it's at the center. So we have two definitions of the center now, right? That point, being 1 over infinity, is imaginary. So we cannot use it. We don't use it. In the same way, we don't use 0 in linear space. But we need it in order to metricize the space. There has to be a 0 to metricize the line, because to get to 1, you have to start at 0. In this system, we need to get to the first counting number when the center number is not 0. It's 1. But that 1 is composed of two infinite numbers, both of them imaginary. This is the correct complexification of space. Two imaginary numbers, not 1. Not the square root of -1. Instead, which is why it's a hybrid system, because the two componency and complexity has imaginarity and reality. In the two componency of spherical space, it's imaginary, imaginary. They're both imaginary. That's correct. That's the correct complexification of space. It's at the axiomatic beginning. That's when you use imaginarity, and that's when you use infinity. And when you componentize those as reciprocal numbers, you have the tiniest number at the center, and it's so tiny it's imaginary. At the edge, you have the biggest number, and it's so big it's imaginary. Here's the center, here's the edge. When you multiply them together and they make one, where must that be? It's between the center and the edge. Right? So when you multiply them together, it makes a surface that's outside imaginarity. It encloses imaginarity. Imaginarity is inside what turns out to be a sphere, and it's harmonically balanced between the center and the edge. That's the number one. And so the surface of the universe, how many surfaces can we count? Well, in linear space it's hard to say what that is, but there are two. In spherical space, there are also two infinities, but one is at the center and one is at the edge. And when you multiply them, it has to be in between the center and the edge, and that makes sense. Because if the sphere has a value of 1, right, and there's nothing less than 1, then what's inside the sphere collapses to inverse infinity. And you don't need to worry about it because you can't get inside. Think of this sphere as solid. It is. It's solid. That's called impenetrability, and that's the definition of the quantum. We just defined the quantum, the point, and the number for sphericity. So, now we have a lot more than what we began with when we first did this. We now have the sphere, and we have the two numbers that define the sphere. We have the definition of the edge of space, and we have the definition of the quantum. I hope you're starting to see how profound this is. But now we need to show that it has value. We need computability now. First, we need to find out where the numbers are in our closed finite universe. We haven't proved that it's closed yet, and we haven't proved that it's finite. But I think you can see that the proof is rather easy now, since we used imaginarity and infinity in their correct relationship, so they define each other. Because infinity is imaginary. And the only definition of imaginary space is infinite space. So, the universe cannot be infinite, or it is not computable. So we're finitizing the universe. The universe is finite. That is actually axiomatic and tautological, although it has been argued for centuries, and our top experts have no clue how to figure that out. And so the universe remains infinite without anybody being able to do anything about it because it's incomputable. That's why we have all the harebrained theories in cosmology, and the quantum paradox is forever incalculable. We're going to solve both problems right now. This is the only way to do it, is by seeing the universe the way the universe sees itself. So, we have a 1 that's a sphere. It has no interior, except that for now, it has no exterior either. We've quantized those out of existence, but they're there. They're imaginary and embedded in the system. Both infinities are embedded in the system. They cannot be used numerically because they're imaginary. But together, Using the proportional identity, they can multiply to the center instead of adding to 0. They multiply to 1, which is a solid sphere. Think of it as solid, because there's no interior. That's the surface of the quantum. The inside is unreachable. That's the definition of the quantum paradox. The space that cannot be reached with your linear numbers. Now you can reach it. Geometrically, we can visualize the quantum. It's the inside of that sphere. And now we can visualize spatial infinity. It's the outside of the outer surface of the sphere. So outside the finite universe is an imaginary space, and inside the inner surface is the reciprocal imaginary space, neither one of which will ever be touched again. They define each other proportionally. That is a key insight into mathematics, geometry, and physics. And we're going to prove it now. The quantum jump in linear spaces from 0 to 1 to get the metric. That's why you need 0. You need 1 for the same reason, so that you can do the same thing we did to metricize the line on 0. We're going to metricize spherical space on 1. So that 1 is the center. And there's nothing inside. That's how we get the number 1. That's how we get the uni in universe, is by having 1 at the center instead of 0. 0 is null. The sphere is real. That's the difference. And that's 2.5 hours. We're going to go on, though. If you just have 0 and 1, you can't do anything. Right? You need to extend the 1 to 2, 3, 4, 5, 6, 7. Those are the linear numbers. Those are the linear whole counting numbers, beginning at 1. It can be proved that those are the only numbers. 1, 2, 3, 4, 5, all the way to infinity, and 0 at the center. You now have 2 infinities. 0 is your derivative infinity, and the end of the line is linear integral infinity. Integral and derivative, infinity, for the line is 0 and linear infinity. For the sphere, it's very similar. Instead of having 0 at the center, the additive identity, you have the multiplicative identity 1. It's fully balanced on 2 componency, so you have no problem. But it's useless. In the same degree that 0 to 1 is useless. You have to extend it. So now we have to extend 1 to get the spherical numbers. What's the number after 1? You may balk at this point, and you should. This is another one of the mind glitches. There's so many of these in this sequence. I think you may have counted 3 or 4 by now. But these are the hurdles in the fish ladder. You have to take this step by step to get the full solution. So is it tedious? Of course it is. But it's real. It's consistent so far. So where are our numbers? All right, we have 1 at the surface, equivalent to 0, but it's not a 0, it's a 1. It's a solid ball. It's a BB. But there's nothing inside. It's undefined what's inside. Only the surface is defined. The surface of the inner sphere is 1 with no interior, but it does have an exterior. It also has an interior, and we're getting to that. You can see that geometrically there's something inside that sphere. It has a radius, or it wouldn't be a sphere. This is part of the quantum paradox, but this is the right way to get at it. Because there's nothing inside that sphere, but we can see there is. Yes, there is. There is the solution to the quantum paradox is what's in there. So now we need to be able to get in. But first we need to have the universe. Because the interior of that sphere is imaginary to the proportion that's what's outside the edge is imaginary. That means that inside the edge is a largest number. And that can actually be defined. The universe is finite. Max Planck proved that. We're getting there. But it also has a smallest number. It has to. Because the reciprocal of the largest number will be the smallest number. Well, we've already found the smallest number. It's 1. So where is 2? We need 2. That's on John Horton Conway's surreal number tree. 1 splits. That's what we need. We need a 2-componency number system to generate physical space. We need the number system for physical space that's not linear and does not have a 0. It has a 1 and it's spherical. So the quantum jump is not from 0 to 1. The quantum jump is from 1 to 2. Correct? That's called the quantum jump. So how's that done? Very easily. In this space, according to what we know from Max Planck's discovery of the quantum for energy, that the lowest counting number in the universe is a split number called wavelength and frequency. And the smallest frequency is 2. The smallest number in the universe is 2. Okay? What's the reciprocal? It's 1/2. That's the wavelength. What do they multiply to? Well, Max Planck said light speed. We're just going to disregard that for now. We're just going to do what mathematicians do and just do the computation. 2 over 1 times 1 over 2. Let me think. That's 1. Well, we just found our first counting number. It's 2 and 1/2. That's a 2-component number. 2 and 1/2. That's 2 to the power of plus 1 times 2 to the power of negative 1. So 2 to the first times 2 to the negative first is 1. So where are those 2-component numbers? 2 and 1/2. The 2 is a spherical shell. So the next one, if we go harmonically, would be 4 over 1 times 1 over 4. So it goes 2, 4. Where's 3? We'll get there. We're just using harmonic numbers because they're the most natural for multiplicative space. 1 over 3 is problematical. And I dealt with this for quite a while, trying to figure out if that's a glitch. Because you would have to be able to know if light quantizes harmonically or linearly. In other words, the wavelength-frequency relationship describes light. It describes light is a 2-component number. The smallest frequency has a reciprocal wavelength. 2 over 1, 1 over 2, that always multiplies to 1. Max Planck said that's light speed. It's been proved, so he's right. But we're just saying light speed is 1. So the inner surface of the spherical finite universe is light speed. And that's equivalent to 0. And the light cone proves that in the 4D to 3D projection, which we then project down to 2D so we can see it on paper or a screen. When we compose hyperbolic Einsteinian gravity space, the constancy of that space is light speed on a cone. Here, light speed is constancy at the inner edge of reality. is a sphere that's 1 and represents light speed, because the two-componency that makes that sphere is generated from two-component numbers, where the jump to 2 is matched by a jump to 1/2 going into imaginary space. If you go to 4, this goes to 1/4, closer to the center on Zeno's paradox. This goes to 8, this goes to 1/8. This goes to the highest number. It can't go to infinity, that's imaginary. That's the edge, you can't reach it. But it'll go to the highest frequency. We have never computed the highest frequency in the universe. Currently, we've measured it into the gamma range, where the frequency is extremely high. It's a high counting number. Max Planck proved that. There are no fractions here except the fractions you're looking at. They're not properly called fractions, although you could. They're proportions. They're proportions between imaginary infinitude and imaginary infinity. This is to make space. So the shells of the spheres go out all the way to the edge and stop at the highest number. Going in, it collapses toward the center in whole spheres until you reach the last sphere before the center. And that sphere has a value of 2. And that's the first real number, 2. You could say that 1 is real because it's the surface, and that brings up a very interesting relationship. The relationship between the two component numbers of a spherical number. We're composing space. All geometry is spatial. And now for another mind wrench, and this may be the most difficult of all, and I hope I make this presentable so that you get it. Because the problem now is, we know that the whole number component makes space. What does the fractional number make? When we linearize the relationship in spherical space, this number goes out 2, 4, 8, 16, 32, 64, all the way to the highest number, which would be the highest frequency of light. If you come back and get the lowest frequency of light, it's 2. The wavelength is 1/2. Where is that wavelength? Where is the half? It has to be real. It can't be inside the sphere, and it can't be outside the edge. The highest number reaches the edge, and that stops, because the universe is finite. Light is finite. It has a highest frequency and a lowest frequency. We know what the lowest frequency is. It's 2. Why can't it be less? Look at the sphere. Think of it as a circle. That just is to simplify the matter. Don't worry, this works for the sphere as well. On the circle, representing the sphere, this is the circle at the center of space. It's the spatial center. It's the spatial surface at the inner limit. Inside is imaginary. At the surface is the number 1. And the shells go out in whole counting numbers. Where do the fractions go? This would be 1/2, 1/4, 1/8, 1/16. All the way to the reciprocal of the highest frequency. This would be the lowest wavelength. Where is it? It's on the surface. And think of the surface now as a circle. And now, turn the circle into the frequency wavelength relationship. The number is 1. right? So that 1 has 2 components, doesn't it? We got the existence of that number by multiplying the edge numbers. These are the surface numbers of finite space. The inner surface and the outer surface. The inner surface is real, but it's the identity. So the sphere is the intersection of space with the other component. What's the other component? You might guess time. Yes, that's correct. Now let's find out where time is. We need to understand what the 1/2 is in frequency 2. We know what the frequency is. It's the spheric quantum jump from 1 to 2. That's the quantum jump that we're going to have to deal with, because that's the metric of the space. The metric, instead of 1, 2, 3, 4, is 2, 4, 8, 16. But they have reciprocals that we haven't defined yet. So that has to be on the surface of the sphere. It's perpendicular to space, just as Einstein said. This is the location of time that's perpendicular to space, as Einstein taught us. This is the way to capitalize on Einstein's discovery that space is orthogonal with time, only in spherical space. The derivatives are also perpendicular, so that 3D space, which is linear, is perpendicular with time, which is linearized. Neither one is linear. They're both spherical. Here's spherical space going out. Now we need spherical time. It's on the surface. And here's how you can compute it. The 2 goes out because there's a split on the circle. What is the split? 2 points. 2 points. Those are the smallest number of points that you can put on the circle. If you put 1 point on the circle, it doesn't do anything. But in 2 componency, it does something. It splits the circle. As space is generated and gets bigger and bigger, the circle becomes smaller and smaller on fractionalization, because the surface of the circle is 1, but at frequency 2, the circle is split into 2 wavelengths. When it's just 1, it's light speed. But when it has frequency 2, then the circle has a number on it called 2, which is equivalent to the sphere. That's the 2 generates the sphere. The 1/2 is the new arc length, which is no longer 1. The arc length of a circle is 1. When it's frequency 2, the arc length of the circle is 1/2 on a periodicity, which is a time measurement. So time is located on the surface of the sphere. It's perpendicular to space. And it's the quantization of the circle to the proportion that space is quantized going out. The surface, which has time involved, is going in by being fractionalized. 2, 4 points makes frequency 1/4. And the highest frequency would be a lot of points. That has not been measured yet. We have not measured yet the upper frequency of light. I suggest that's a valid subject of research. Try to find the highest possible frequency of light. We don't know that number. It's never been discovered. We only know that gamma rays are the highest frequency light so far discovered. Protons can emit gamma rays. It'd be a very good idea to measure the frequency of protonic radiation. because that's a candidate for the highest frequency in the universe. And that would be the highest counting number in spherical space, beyond which is infinity, because you can't go faster than the speed of light. That's the meaning of the constancy of the speed of light. It's the finity of the universe. So, we've now discovered a new relationship on the surface, the relationship between the number of points and the arc length. That 2, 4, 8 are the number of points, and that means the sphere is going out according to the number of points in the periodicity of the circle. This is the direct relationship between space and time, which we now need to correlate according to the 2 that's on the circle. That's the number of points. So the first counting number in spherical space is 2, 1/2. Those are the 2 components. Space is the whole number. But what is that fraction? If you consider the 2 to be the 2 points that divide the arc length in half, then you have a very good working definition of the relationship between space and what's happening on the circle. Consider this now. Since we're measuring on the circle, remember this is actually the sphere, but it's just easier to picture as a circle. That is a continuous line, which means it has no meaning except in terms of motion, and this has never been in any geometry. It can't be in linear geometry because there's no continuity, but we're going to now find the continuity that exists on the sphere. That surface is continuous. It's a closed line, and so it's not measured with spatial separation. It's measured in temporal separation. And this is a very elusive and complex notion, because from this notion we derive our concept of time. But time is not a thing. It's a derivative of the sphere. And we know that because the 2 points are one of the derivatives. It's called the frequency. That's a derivative of the sphere. And the reciprocal of that is the wavelength, and that's the fractionalization. But that's not in space. It's not space. It's not space. Space only goes out from the surface. On the surface, there is no space. That's not space. That's the center of a 2-component number system. So it's the inner surface of space, but it's the outer surface of energy. And it's energy that we're looking at because of motion. This circle has no meaning except in terms of energy, because energy is motion. And that's the correct definition of energy. It's a motion. Energy is motion. It's not spatial. Energy is not spatial. We're finding that out from this geometry. Okay. So we found the elusive component of universal space that baffles our physicists. It's essentially time, but we can trace time to motion, and we can trace motion to energy. Let me give you some terms so that we can go on in a comprehensive fashion so that it does not overwhelm you. This might be a good time to take a break. We're approaching 3 hours. We found space, and we can define it by whole numbers. 2 to the highest number. And that's finite space that fully defines the universe in the only way that makes sense. Because now we can deal with infinity. It's in the system. Here is where you find out the rather baffling aspect of time. That it simply cannot be linearized the way Einstein did. Because if you linearize it, you quantize it. You must not do that. Because if you quantize it, you've lost two componency. It has to be proportional to something. Well, time is proportional to space. But that's incorrectly stated. Time is a very, very strange concept. Because we know that it's real, but it's impossible to measure. We have no way to measure time. We do now. Time must be quantizable. For the same reason that space must be quantizable. But it's not linear quantization. So the quantum jump from the surface to the first ring of space, the spherical shells that fill space, from the inner edge to the outer edge, totally consistently. This is also a closed system, because even at the imaginary edges, it still multiplies to light speed. So inner infinity and outer infinity multiply to light speed. Even though they're imaginary, they multiply to light speed. That is the definition of the universe. Absolutely rigorously proved from geometry and mathematics. We now have the definition of the universe for the first time in computable form, eliminating the problem of zero and eliminating the problem of infinity. We've got it all. And we've got it on the frequency wavelength relationship. And now all we have to do is dissect the spherical surface to find out the relationship on the sphere of motion with space. This motion is centrifugal force. Centrifugal. It has to be, because it's an outer pressure. So the centrifugal force generated by the sphere generates space by motion. And it's on the periodicity of this motion that we get the generation of space. So what is being fractionalized? Periodicity is. And that's still elusive. We haven't hit the core yet. So let's go one more step and then we're going to cut this off. This surface is only partially spherical. I'm sorry, let me say that differently. This sphere is a surface. It's only partially spatial. It's not actually space itself. Space itself begins at the number 2 off the surface. What makes it jump? It's energy that makes it jump. So space is constructed from energy. Well, energy is constructed from space because this sphere embodies both relationships. As energy is manifested on the sphere, it manifests space going out. But reciprocally at the same time, to put it weirdly, as the motion generates space, the way that space is being generated is by dividing the circle. So higher and higher frequency. The lowest frequency makes the smallest amount of space spherically going out. It's the quantum jump from 1 to 2. That's the quantum jump from 1 to countability. And the reciprocal, which has to be there, is on the sphere in its fractionalization. That's a different data type. It's not spatial. And because of our linear logic system, we cannot conceive of that as being measurable. That's the quantum paradox. Is what's happening on the sphere cannot be measured linearly. We think we can measure the spheres because we can get the radius. But you can't do that going along the sphere, because that is continuous and you have to linearize it another way. And that's by the fractional component. It linearizes the circle. That's what the Greeks failed at, and everyone has failed at since. We just linearized spherical space. I hope you enjoyed that. That's 3 hours. You can tell that I could go on for another 8 or 16 or indefinitely number of hours. We will, but we need to break this into pieces so that we can not wear ourselves out. I myself am a bit fatigued right now from having given you a 3-hour lecture. This is Anagalactic, bringing you the secrets of the universe. There will be information at the anagalactic.space site to support everything that I said. But I recommend that you listen to this video again if you need to be sure of my proof. The full rigor of my proof can hardly be expressed because this is the most difficult problem that science has ever faced. Correct? Obviously it is. So to get this kind of an answer at the actual axiomatic basis of mathematics and geometry and physics is going to be difficult. So I hope I made it easy. That is my job. Stay tuned. We'll have a lot more. But I'm worn out. And so I leave you now to go back to my studies so I can prepare more for you. So that you understand the universe and you're not prey to these monsters who are destroying everything. That humanity has worked so hard to get this far. To not take the last step would just be the most criminal act of negligence. I will not go to my grave letting these monsters dictate to us their fantasies when reality is there to be had. Beginning at Euclid and going past Einstein, we're going to get it all. And in the next series of lectures, I'll come back to the quantum paradox system to show you the applicability of spherical numbers. And then we're going to go on to what I've always wanted to go on to, deep space, to describe the wonders of the universe in a way that will make you grateful that you are able to see as clearly as you will be able to see. And I hope you've achieved that to some degree, but I'm not going to rest. I'm going to make sure that somebody gets this. That's my job as a scientist. This is Anagalactic. Keep looking up. We'll be right back.